Can you guys believe we're still on 4.4? So this is the never-ending section. There's a ton of information in here. So today we're on day 4, and we're going to look at the definite integral of the rate of change. That sounds really wordy, but if you take it apart, you know what a definite integral is, right? That's when we integrate, let's say, from a to b of f of x dx. But now all we're saying is we're going to integrate the rate of change. Well, what's the rate of change? The derivative. Okay, so that's what we're going to look at today. That's all that means. We're going to build up to it as always. So let's start by looking at this example. This is something that we could do. They give us the derivative, and then they give us the value of the function. When x is 0, it's 5, and then they're asking us to find another value. Okay, so we're going to do this 2 different ways. A is going to be something that we're used to doing and that we can totally do without learning anything new. So it says find the particular solution. You guys remember that means we have to have a number for c to the differential equation, then evaluate the solution at 2. They say that because they're asking for f of 2. Okay, so let's go through this and find the particular solution. Do you remember to find the particular solution, we first have to find the general. And it's really saying find f. But we have f prime. So we are going to find f. We are going to integrate f prime. We're going to make sure we write our dx on that. Okay, when we integrate that, we are going to get 2/3 x cubed minus 2x plus c. What we just found was the general solution. Okay, now we're going to go on. So we found f of x is 2/3 x cubed minus 2x plus c. Now they gave us this value at 0, the output is 5. So that allows us to find the particular solution. What we're going to do now is say f of 0 is 5, and then we're going to go ahead and throw a 0 in. What this is going to do is allow us to get c. So 5 equals c. Now we can say, okay, now we know that f of x is going to be 2/3 x cubed minus 2x plus 5, and this is the particular solution. So looking back at the directions, they said go ahead and find the particular solution, then find the value at 2. So now we're going to sub 2 into our function. And go ahead and calculate it. So this first part is 2 cubed is 8, 8 times 2 is 16, so 16/3, and then we're going to have -4 plus 5, which is +1. So now I can say f of 2 is 19/3. Okay, so if we already know a way to do this, why are we going to learn another way? Well, let's think about what we did. The first step was to integrate this, right? If we didn't know how to integrate this, like if this was a function we didn't know yet, what would we do? Do you get we couldn't proceed? Like if we can't find this general equation, we wouldn't have been able to sub these numbers in. Okay, so on this problem also, one thing to note is you can't use a calculator. Remember, your calculator cannot compute an indefinite integral. They can only compute it a definite when you have numbers there. And remember that awesome button was Math 9. Okay, so those are the problems. If you want to jot those down, we couldn't use a calculator. Maybe I'll add those for you. So the issue is you can't use a calculator. So you'd have to integrate it by hand. Well, what if you can't integrate it by hand, right? Then we'd be stuck. So what's this next one saying? It's saying use a definite integral. So first I'm going to start, and I'm going to jump down here with this good to know thing. And this is just kind of common sense, but it's nice to see how it relates to math. Okay, let's look at the first one. Where you are at any given time is a function of. Okay, let's say right now, where are you at? You're where you started, okay? So if you start right now where you're at, and now let's say you get up, and you can go ahead and get up off your seat right now if you want, and walk 5 feet to the right. So where you are at any given time is going to be where you started, which was in your chair, and then where you've gone from your starting point, which is your displacement, right? You could also start in your chair, run all around the room, end up 5 feet away, and that's still going to be where you're at, okay? Another thing, what you have in any given moment. Let's say, how much money do you have on you right now? Let's say you have a $5 bill, right? That's what you started with. Now, let's say you're going to get paid for doing your math homework. So let's say you did all your problems and you got $100. How much will you have at any given moment then? You're going to have what you started with, which I think I told you was 5, plus what you've accumulated. If you got $100 for doing your math, you're now at 105. So the whole topic today is to say where you start, to find out what you started with, that value, and then add or subtract what you've accumulated. Now, if you had $5 and let's say you didn't do your math and you had to pay someone $100, you would have 5, and then how much have you accumulated? Actually, none, you lost. So then you would minus 100 and you'd have negative 95. That's how we're going to look at this today. This definite integral of the rate of change is going to help us with this idea of accumulation. Okay, so now back to this problem. That was a little side note. What do we want to end up with? They asked for f of 2. F of 2 is going to be like your $105. It's how much you ended up with. So f of 2 is what we want. Okay, this is going to be the y value at 2. How are we going to find out how much we have at 2? Well, we're going to find out what we started with. What did they tell you? They told you up in the problem that f of 0 is 5. So this is going to be f of 0 plus. Now, here's the cool thing. You have to find out how much you have accumulated. Well, do you remember that the definite integral gives you net change? If you need to look back at your notes, that was first fundamental theorem, which was the first day of 4.4. So here's where this new thing comes into play. If I integrate 0 to 2, now why did I choose 0 and why did I choose 2? I want to end up at 2, and 0 is where I started. So I'm integrating from 0 to 2. This is going to give me the net change, and I'm going to integrate f of x. The reason I'm going to integrate f prime. The reason I'm going to integrate f prime is, look up here. We started off by saying if we integrate f prime, this is going to give us the net change in f from a to b. So this is going to give me how much I've accumulated from 0 to 2. So let's take a couple notes about this. This is the y value at x equals 2. This is going to be my initial value. So it's going to, f of 2 is how much I ended up with at 2. F of 0 is what I started with. And this interpretation is my net change. It's the accumulation of y values from 0 to 2. That's a t. Okay, this is going to be my accumulation. This is like my $100 that I got for doing my math problems. Okay, so now watch how cool this is. This is what I want. We know f of 0 is 5, and then I just have to integrate. Now, the cool thing about this is after I set this up, and I'm going to do it by hand to practice with you. I got that from the problem. Is what was the issue over here? We couldn't use a calculator, right? So if I couldn't integrate this by hand, I was done. There's nothing I could do. But look over here. Do you see that now we have a definite integral? Go ahead, type away, math 9 that, and get your answer. Okay, but we will do it by hand, but you could have used your calculator. Another thing, we never found the general solution, right? The general solution was a means to an end. We really never said, here's my answer. We just used it to get the particular. We don't care over here. Type this in and be done. Okay, but we're not going to because we need to practice. So this is going to be 2x cubed over 3 minus 2x from 0 to 2, which is going to be 5. And then if I sub a 2 in, I'm going to get 16/3 minus 4 minus 0. And then I'm going to get, do you guys see this is now 16/3 plus 1? And look at, lo and behold, same thing over here. So then we get 19/3, oops. So f of 2 is 19/3. And again, if you have to show your work, you would have to go through and integrate this. A lot of times on the AP test, you'll see that the function, you can just type it into your calculator and you would have had your answer right away. Okay, this again is the new thing today that we're going to focus on. Okay, this next line just restates what I already said, that the first method we had to be able to integrate by hand. The second one, we could have used our calculator. Good to know we already spoke of also. Okay, so this important idea of accumulation, this is what today's lesson is. And I really need you to understand the meaning behind this because a lot of these problems on the AP test, you have to understand the meaning. It's not just being able to integrate by hand. You have to be able to set this up. Think of it this way. What you have now is what you started with. You have $5. You've accumulated. You did all your math and got 100. You now have 105. This is what you want. This was our f of 2 from above. This is what you started with, which was our f of 0. We integrate from 0 to 2. Our derivative, okay? A fancier way to look at it, the net change theorem, is the definite integral of the rate of change of f prime gives you the total change or net change. I'll explain what this means right here, but do you get that this is the same thing from above? Now they're just using capital letters here, and it doesn't really matter either way. Okay, I wanted you to see it both ways. But let me explain to you how this came about, first of all, and then how we can go from here to here. So off to the side here, what happens, let's say we don't know this, and let's just do this. If we integrate this, well, what do you get when you integrate capital F prime? You're going to get the original function. So you're going to get capital F of x from a to b, which gives you capital F of b minus capital F of a. So do you guys see that? Right here. This is how we got the net change. When you integrate capital F prime, you're going to get fb minus fa. Now what you can do is if I want to solve for f of b, so let me copy this over again just so you can see it all on one line. When you solve for f of b right here, all you have to do is add f of a to the other side. So that's going to give you capital F of b is going to be capital F of a plus the integral, and now you can see how it matches. Okay, so I went over it two ways. Up here, I was talking about, making sense of it. You have $5, you get 100, $5 plus 100, you end up with 105. Now here's the math on why it's working. Okay, going on to this. Look at, they gave you the derivative. So I want you to start noticing patterns, right? Like when you see this, you think something. When you see little f prime and they ask for little f, you know you're going to have to integrate. They gave you one of the points, and now I'm going to ask for f of 3. So if you go ahead and grab your calculator, let's set this up though. Okay, so to set this up, I want f of 3. That means I'm going to say, what did I start with, which was f of 2, and then I'm going to add the definite integral 2 to 3 of f prime dx. Now this, it says using your calculator. When you use your calculator, do you get that I really don't care what this function is? It's f prime, right? I don't need to write it out. They already called it f prime. And I don't need to integrate this by hand. So little f prime is fine. I'm asking you to use your calculator. I want you to see how quick this will go. So go ahead and grab that. Okay, now because this problem is asking us to do like A, B, and C, multiple things with the same function, we did this earlier that it's easier just to type the function into y1 and then we can just keep referring to it as y1. So we're going to have 4 and then we have to square sine. So I'm going to put parentheses there and then we're squaring sine of 2x, close the parentheses, square it. Okay, so now that's y1. Go back to your home screen now and let's type this in. If you look at the paper, it said f of 2. Well, what is f of 2? F of 2 is negative 2. So we're going to go ahead and type in a negative 2 plus, we're really just typing exactly what's on our paper. We get math 9, and our bounds go from 2 to 3. Now, instead of having to type 4 sine squared of 2x every time, we can just type y1. We already entered it. So hit the variable key. It's right here. Go over. Hit enter, there's y1. Go ahead, throw a dx on that, and let's see what we get, 0.763, and it's as easy as that. Okay, I hope you guys are loving this net change theorem, the accumulation idea. We round to 3 places always, so 0.763. Okay, back to our notes. So we're right here, we can say f of 3 equals 0.763, and we're done. Okay, pretty cool. Okay, going on to the next one. Why don't you guys try this one on your own? We already did one together. Go ahead and try this. Hit pause, try it, and we'll meet up in a sec. Okay, hopefully you guys started by writing this. I want f of 5. I started with f of 2, so I'm going to integrate from 2 to 5. If I want f, I have to integrate f prime to give me the accumulation. I'm going to go back to my calculator now. And we can actually just go up here, hit enter, and then edit what we have. So this is really working out for us. Everything looks the same, guys. Compare A to B, except the upper bound is now a 5. And we get 4.038, rounding to 2 places. I mean, that took us like no time at all. So 4.038. Okay, on to C. You could probably stop and try this one on your own also. We want f of negative 2. We have f of 2. Okay, now look what we have here. The numbers are a little out of order, but it really doesn't matter. It'll flip it for us. So right here, I started at 2 and ended up at 3. Right here, I started at 2 and ended up at -2. So when you write this, you get this. Now remember, we learned this thing that if I negate this and switch the bounds, it'll be fine. But if we type it in like this, it also is going to work out, okay? So I know it looks weird that this number is bigger than that number, but that's okay. We're typing it into the calculator. When you subtract, the signs will take that into account. So I think we just go here. Look at, easy enough again. Highlight, enter, go over. Now this is, oops, too far. This is a -2, enter. And now we get -9.011. Okie doke. So over here, f of -2 is -9.011. Okay, hopefully you're seeing how to set these up. Now they're saying, okay, we get that you could do this for 3, 5, and -2. Could you do this for any given x? Sure. If we wanted f of 5, or let's go here so we can see it. If we wanted f of -2, we started with 2. And the -2 went here. Now what they're saying is, we don't want -2 necessarily. I want it to be a function of x. So a function of x is going to be what I started with. Then I'm going to integrate from 2 to x. Do you guys see these matching? And then I'm going to integrate f prime. Now here's where the tricky part comes in. This previously was x, but now I have x here. So this variable has to be different here. It doesn't matter which one you use. Quite often t is used. You just have to make sure you choose something not x. So choose a different variable, your call. Okay, on to the next problem. Now, this is asking us something very similar. Okay, as we do 3, I'm going to do example 3A, and then I'm going to go down to 3B, to 4A. I made these problems so that you could see a comparison. You have to be careful in your interpretation of your answer and what you're finding. So if you're given that f of 0 is 6, and there's the derivative, they want you to find f of 3. This is very similar to what we were just doing. So if I want f of 3, I'm going to start with f of 0. I'm going to integrate from 0 to 3, and I'm going to integrate this function. We did the other ones using the calculator. Let's go ahead and do this one by hand. So f of 3 is going to be 6 plus, if I integrate this, I'm going to get, let's see, x cubed over 9 minus 2x squared. I said minus, plus, from 0 to 3. Okay, if I sub a 3 in, so if I sub a 3 in here, I'm going to get 27 over 9, which is 3. Plus 18 minus 0. So f of 3 is going to be 6 plus 21. F of 3 is 27. Okay. Notice on this problem, they ask for a specific value, like f of 3. You use the definite integral here to be able to get your answer. Okay. Now I want you to go down to 4 and see what that's asking. This is just asking us to integrate this. So when I integrate from 0 to 3 of 1/3 x squared plus 4x, do you notice I'm not adding on a number to it? I'm just finding this answer. So we did this above. This is going to be x cubed over 9 plus 2x squared from 0 to 3. This is going to be, if I sub this 3 in, 27 over 9 is 3. So 3 plus 18 is 21. This is what we're used to doing. We're used to integrating a definite integral. What I want to do right now, though, is I want you to interpret this, because this is what we're going to have to do with this. 21 is the net change in f from x equals 0 to x equals 3. You're going to have to write this sentence out a lot on application problems. They love asking this kind of question on multiple FRQs. Okay, so what we just did, again, I'm not focusing on this. Notice how fast I went through this. You guys are integration experts. Now I need you to do, what I need you to do is interpret what this 21 is. You found out the net change in f, and I'm saying f because f prime's above, from 0 to 3. Another way that might help you to understand what we just did is if I look at x and f of x, look at the information from above. They tell you at 0 you get 6, and at 3 you get 27. So at 0 we got 6, and at 3 we got 27. What is this difference here? Isn't it 21? That's your net change. So if I started with 6 and I have a net change of 21, I end up at 27. This question asked, where did we end up at 3? This one did not. This just said, because they were just integrating, find the net change. So I need you to see the difference between the net change and the accumulated value, like where you end up. Okay, let's do the same thing over here. Okay, so let's switch pens. I want g of 0. So I'm going to say, well, I'm going to go g of 4 plus, I'm going to go from 4 to 0 of x cubed minus 3x dx. G of 0 is going to be 12 plus, we have x to the 4th over 4 minus 3x squared over 2 from 4 to 0, which is going to be 12. Now if I sub a 0 in, everything's 0, minus, now if I sub a 4 in, 4 to the 4th over 4, that's like 4 cubed, which is 64, minus 4 squared is 16, divided by 2 is 8, and 8 times 3 is 24. Oh, forgot my plus sign there. Okay, so this is going to give us 40. We have a negative 40, so I'm going to have 12 minus 40. So g of 0 is negative 28. Okay, now let's do the same thing below, but instead of asking for g of 0, instead they are just asking us to integrate. So we're going to go through this, 0, 4, x cubed minus 3. I don't know why I wrote that again. You guys don't have to do that. Okay, so you're going to get x to the 4th over 4 minus 3x squared over 2 from 0 to 4. Notice here we're going from 0 to 4, and above we went from 4 to 0. Again, it didn't matter, because if you look up here, right, we ended up subtracting, which took everything into account. Okay, but they set this one up differently, totally okay. This is going to give us 64 minus 24. So let's interpret this. We just got 40. What is 40? See if you can write it. 40 is the net change. They called it f prime above, so, or g prime, so we can say g. It's the net change in g from x equals 0 to x equals 4. So we changed by 40. If we want to make that chart again to make sure we understand it, what did we start at? Look up above. G of 0 was negative 28. And what else did they tell us? G of 4 is 12. Well, what is this different here? Isn't that difference 40? 40 is your net change. Okay, I hope that helps to clarify and for you to see the difference in what we're asking. Okay, now on to an application problem. Calculator, oh great, no more calculating by hand. Let's read through this. So a chemical flows into a storage tank at a rate. Let's highlight that. If they give us a rate, that's like a derivative. And look at the units, where t is the time in minutes and time is between 0 and 60. There are 500 liters of chemicals at time equals 0. Okay, a couple things to note. When they give you the rate, liters per minute, let me just write this down off to the side. I'm going to come back and analyze that in a second. Let's read the A. Find the amount of chemicals that flows into the tank during the first 20 minutes. Here's the question you have to ask yourself. Are they saying how much is in the tank at 20 minutes or how much did it change by? Those are different questions. Up above, this is the net change. How much did it change by? This, when they ask for a specific moment in time, it's how much is in there at that moment. So let's read through this again and try to figure this out. Find the amount that flows into the tank. Do you guys get that they're asking how much did it change by? Like how much entered the tank? Not how much is in there at the end of 20 minutes, but how much entered during that time. Liters per minute. If I'm finding the amount of chemicals, right, that's going to be in liters. So I want liters, but all I have is liters per minute. Well, if you integrate, you go up a notch, and we're just going to get liters, right? If I took the derivative of liters, I'd get liters per minute. If I integrate liters per minute, I'm going to get liters. Okay, so we are going to go ahead and integrate this from 0 to 20 because it said the first 20 minutes. So I'm going from time equals 0 to time equals 20. Be careful, you guys. This has a t in it. I know it's easy to use x. I'm sure I do that sometimes. Oh, did not do that on purpose, but totally proved my point. And you want to make sure you use t. This set calculator. All you have to do is type this into your calculator. So let's do that real quick. There's a part B to this. So I want to go to Y1 and I'm going to change this and I'm going to enter 180 plus 3t because I see that I'm going to have to do something else with this function. So I don't want to enter it multiple times. Okay, I'm now going to go back to my home screen and let's calculate this. Math 9, we're going from 0 to 20. The function, we probably could have done this by hand, maybe quicker than we can type it in. Oh, we don't want to type this in. We want to use Y1. You hit the vars, the variables key, go over, hit enter. There's our Y1, dx, and there's our answer of 4,200. So this is 4,200. It's a story problem. Let's write out our sentence. Find the amount of chemical that flows into the tank. So we can say, maybe the sentence would look better if we said during the first. Let's start. During the first 20 minutes, what was our answer? 4,200. Don't forget units, liters, flows into the tank. Liters flows into the tank. Okay. We don't know how much is in there at 20 minutes. We just know how much it's changed by. Look at B. Find the amount of chemicals at T equals 60. Okay, this is a game changer. Now this is saying this does not just want net change. And let's make a note. This one wants net change. The second one does not just want net change. The second one wants a quantity at a specific time. Okay, so let's go ahead and do that. How are we going to find out how much is there at T equals 60? Well, we're going to say how much did we start with. They told us we had 500 liters to start with. So it's going to be 500 plus, well, what was 500? Wasn't 500 the value at time equals 0? So we're going to go from 0, and they want us to find out how much is in there at 60. Then we are going to go ahead and integrate our function, which is 180 plus 3t dt. And look at, this is going to give us the net change, and this is plus how much we started with. Okay, back to our calculator. All we have to do now is take this, and now what are we going from 0 to 60? And then we're going to have to add on, let's get that answer, and then we have to add on the 500 that we started with. And we're going to get 16,700. 16,700 is our answer. So what could we say? We could say for at T equals 60 minutes, there are 16,700 liters. Okay, I hope seeing the side by side helps you to understand what they're asking. Okay, going on to this one. From 1990 to 2004, the production of apples, and they give us that. Okay, did you guys understand something here? Bushels per year, that's a rate, where T is the number of years beginning in 1990. Find the total number of bushels produced from the beginning of 1990 to the beginning of 2004. Ask yourself this, are they asking for how much quantity at a specific time, or are they asking how much it changed by? Find the total number of bushels produced from the beginning of 1990 to the beginning of 2004. Take a second and pause it. Okay, hopefully you got this, that they want net change. So all we have to do to get net change is we are going to integrate. They said we could use our calculator. Now, they said T is the number of years in 1990. So 1990 is 0, which would make 2004 14. You could go ahead and write the whole function out, or you can just write P of T dt because that's what they named it. We're going to go to our calculator, type this in, and call it a day on the story problems. When you go to your calculator, now here I'm not going to enter it in Y1 because they we're not going to do more than one thing with it. There's not a part in part A or part B. If you want to do that because you're used to it, go ahead. It really doesn't matter either way. This is 1.3 plus 1.025 to the x dx. And we get 34.925, 34.925. Okay, let's go back. Okay, what is wrong with our answer? Did you guys see it said thousands? So it's actually 34,925 bushels that we got. Okay, the next problems are just some review. They're similar to problems on your worksheet. I thought it would be nice if we went over them together. Looking at this problem, think about what section this comes from, guys, in 4.4. Remember, we've done 4 days of it. They give you capital F. Our lower bound is a number. These x's match up, and this is t. I would like you to try this on your own and then meet up with me. Okay, I'm going to go on. So if I have f and I want capital F prime, doesn't that mean take the derivative? So we're going to take the derivative of the left, and we are going to take the derivative of the right. Okay, are you guys seeing that this is second fundamental theorem? If I take the derivative of capital F, I get capital F prime. What we're thinking about here is derivatives and integrals. They kind of undo each other. This goes in for t, and the biggest thing is don't forget to multiply by the derivative of the upper bound. So if x squared goes in for t, I'm going to get 1 plus x squared cubed, and then I multiply by the derivative of the upper bound, which is 2x the square root of 1 plus x to the 6. And where is that? This looks like a multiple choice. It looks like it's letter A. Okay, going on to 8. It says capital F and little f are continuous functions such that capital F prime's derivative is little f. Then they're saying, well, what will this give us? Okay, let's write this out. If I'm trying to integrate little f, what am I going to get? Well, you don't have to write it this way, and this isn't like proper notation, but one way to look at it, so this doesn't have dx, but what if I integrate both sides? The integral undoes the derivative, and isn't that just capital F? So they're saying capital F, you know what, let me throw some dx's in there. It just looks, okay. So then capital F is going to be the integral of little f. I hope that made sense to you. If not, we can talk more about it in class. But by them just saying that capital F prime is little f, I need you to understand that if you integrate little f, you get capital F without the prime. One way to see that is by seeing if you integrate both sides, the integral kind of takes out the derivative and you just have capital F. So when I integrate little f now, I'm going to get capital F from A to B, which gives me capital F of B minus capital F of A, which is D. Okay, that's a wrap on 4.4. Day 5 of 4.4 tomorrow is particle motion. I'll see you then.